Hello. Oh, nice. So Paul, you have the floor.
Thank you. Hello, everybody. I'm Paul Jung, working for Excellium. It's a firm located in Luxembourg. If you understood very well what I said in English, that's maybe because you are French also. So we'll talk about sandboxes. We use sandboxes, and we love sandboxes, and people are selling also sandboxes. But there are some issues. We will take a look at that. So now, yes, it works. It's okay. So now, every malware, every sample that is sent through a campaign is mostly unique because it's packed. You have a clocking layer around the executable, so it's really time-consuming to analyze it. So the idea is for you, if you are a reverser, or for firms, if you want to protect yourself, the goal is to, for the malware, the goal is to come to the workstation here at the bottom. So companies have mails, companies have download through internet, and security firms have another idea. The idea is to, let's put a sandbox. It will analyze. If it's bad things, it will alert you. Like an EDS was a bullet device a few years ago, now it's a sandbox. So, I really have a problem with that. So what those sandboxes do? Oops, sorry. Okay, I'm sorry. Just it's a Mac. It's so easy for most of people, but not for me. Really nice. That's fun. Okay. Works. So, yeah, slide and okay, I'm ready. So the sandbox is just a PC that runs the malware. So it's dropped on the sandbox. The sandbox usually use maybe operating system, Windows 7 or Windows XP most of the time. And it hooks every API calls and every kernel calls for the best of one. It captures traffic, and it's of course rely heavily on virtualization because it's easier. It's easy to deploy your workstation, launch the malware, and clean up after that. So, the problem, why we need a sandbox? Because we need sandbox. The sandbox need to run on the target at the end, the workstation, not on the sandbox itself. So, why do we need to detecting sandbox for malware purpose to slow down the reverser? If you detect the sandbox, you are able to do nothing or to do something which seems legit, and you have no idea what to do the sample or the packer itself. So you gain time for your infection. Well, there is a lot of sandboxes now. Some are free, some are used and paid, and you paid a lot of that. And I use it. A lot of people use it, and more people are selling that. You maybe recognize the quadrant. Today, we will talk how to detect the sandbox. We will take a look at what is commonly used in malwares, and we will also take a look at where I found how to detect a sandbox without calling an API. So, you have a lot of virtualization now. So, if you detect the virtualization, maybe you detect the sandbox or malware. If you are targeting workstation, they don't use virtualization. So, if you detect the virtualization, maybe you detect a sandbox. You have a lot of virtualization player, KVM, VirtualBox, FireEye, which have its own made, they said, Xen, VMware, and so on. So first, VMware. It's really old in virtualization. It's well-running things. And VMware leave a lot of traces in the registry. And in processes, you have some service. If you install the tools, you have service. You have executable, which are running in memory. And you have a huge footprint in the registry also. If you install the VMware tools, you have, for example, here 500 keys with the VMware inside. And if you don't install the pools, you still have a lot of strings with VMware inside. So, for a malware point of view, it's a good thing to seek for the string VMware in the registry. And it is really used. That's an example. The malware just take a look at the controller in the registry, at the disk, sorry, not the controller, and he try to see if it contains QEMU, virtual, VMware, and Xen. That's used. What it's also done with virtualization. The MAC address of the virtual workstation have MAC address which are linked to the vendor. If you have VMware, you may have some well-known MAC address. For Hyper-V and for Xen, it's the same. So if you want to really be stealth, you have to change the MAC address. So other techniques in the wild, so software companion, the tools, virtualization footprint, we have seen that. And you have also the virtualized hardware. If you have virtualization with a VirtualBox, it will be always the same video driver, which is not normally used anywhere in the world. So if you take a look at the devices, information in BIOS, information in the drivers, and so on, you are able to see if you are in a potential virtualized machine or not. You could take a look also for detecting virtualization at serial numbers, because some malware sandbox will use the same software. It's packed, it's images, and you always have the same serial number on the disk. So it was used. It's not really used anyway because all sandboxes are now generating unique numbers. But this is not so old, and you still have some people which are looking to serial numbers of disks. Alors, techniques in the wild. How to bypass a sandbox? Just use 64-bit softwares. You have a lot of sandboxes that do not use already something to be able to run 64-bit software. So there is a small air gap. It's filled. A lot of vendors now are using 60-bit sandbox also. So it's the gap is reducing, but there are still a bit gap. Oops, sorry. What you could do also, it's take a look at the browser history. If it's a sandbox, browser history will not move a lot. If it's a real person, it will have some event of today. And if the sandbox is root stage, the history will be also root stage. So vendors are now done a quite good job on that. You have some history generated and so on. You could also take a look at the running application. If you are sending malware through mail campaign, you should have Outlook open on the workstation. If Outlook is not running, maybe you are in sandbox. You could take a look at the domain membership. If it's designed to be used as a penetration for a firm, you are probably in an Active Directory domain. So if you are in an Active Directory domain, you may be able to look at that. To see if you are in a domain, you just have to take a look at some environment variable. If the logon server is not the same as the workstation server, you are in Active Directory. If not, you are maybe in the sandbox. You could use user interaction. A real user moves the move. It types something, and normally, if nothing is moving, you are probably in a sandbox. All that the strings are quite well detected now, and the problem with the sticks that if use API, if it's use API, the sandbox will log it. So you may bypass, you may detect that you are in a sandbox, but you are also detected. You are trying to escape the sandbox, trying to bypass the sandbox. So it's not a good thing to use API with detection of sandboxes. So all myths. There are a lot of things available on the internet. If you take a look at how to detect a sandbox, you probably come to this part of code. That's the way the VMware client talks to the hypervisor. It uses import to read in the port, and normally it's a privileged instruction. It should not working, but if you have the tools, it works. So it could be used in user space in user land. If you configure your VMware workstation with these 4 parameters, it will not work anymore. But as ever, never install the tools. Other things, there are some bugs in emulation, but it doesn't work anymore also. You have some instruction error on EM and ZLC, ZIC, which is not implemented on some old version of QEMU. And you have the famous red pill, which is not working anymore. So how to detect a sandbox without using API? It's still possible. So it's quite stupid. How many brains in the box? So since now 15 years, you have multi-core. So you have hyper-threading. So you have multi-CPUs and hyper-threading. So you never have only one CPU. It's clear. And if you take a look at some sandboxes, and currently, you may see that you have one CPU. How to see how many CPU you have without using API? You just have to ask to the PEB, process environment block. It's an opaque structure, but everyone knows it. It's well documented. And inside this structure, look at it at the well, 30. You have the number of CPUs at Windows C. You can tell if it's how many cores or how many real CPU, or is it hyper-threaded or not, but you have a count. If you are 2 or more, okay, it should be clear. But if you have only one, it's probably virtualized. It's easy to do, really easy. And it works on some malware BotConf, for example. It works really well, and other vendors also. So it's a way to see how many CPU you have. It's a way to see if it's virtualized or not. How to detect virtualization without API? You have other ways. You have the CPU ID instruction. So CPU ID instruction is Intel instruction. It's non-privileged. Everyone may call it from the user land. It's like an API to query feature of the CPU. So you have to fit some registers, you call the instruction, and all registers will be changed and filled with information. It's hooked by the virtualization. So the virtualization layer will change and move this information, but you have always gap. First, if you use CPU ID, you just have to ask if it's hypervised or not. If it's hypervised, you have a bit which tells you that you are running in a virtualized machine. It's also easy to detect that because it's really easy to implement. You just have to put one in EAX and call CPU ID. And the last 32 bit of the result of EAX will give you if it's virtualized or not. That's the first point. It's easy to detect. It works well for some virtualization engine, VMware, for example, but not for others. So you could use leaf 4 million. With a 4 million, you have a string of the virtualization. So it's hooked by the virtualization engine, and it gives you the string. It tells you which kind of hypervisor it is. So it's usable. Again, it works well for virtualization that you implement yourself, but it don't work for virtualization on anti-sandbox on sandbox devices. So how to detect it? Still using CPU ID. At the left, you have normal Windows. At the right, you have the same CPU ID, so it's a tool CPU ID, and give you some information. As you see, there are some changes, little changes, but it's not easy to detect. For example, on VMware, okay, you have some changes in the instruction capabilities, but it's not easy. You have to build a table. For others, it's really easy. If you take a look at VirtualBox, you have a little problem. You don't have a layer 1 instruction cache, and no Intel CPU since years and years don't have any layer 1 instruction cache. So if you take a look at that, you are able to say if you are in a sandbox or not. What else? If you take a look at your Windows, you will have, for example, in this case, we have 2 CPUs with 4 core and pair threading. So if I ask to the PUB how many CPUs I have, I should have 16. But with CPU ID, you may ask to one CPU. You don't know which one. It depends, but if you don't call you don't know which one. Who cares about that? We choose one, and we are able to tell if it's hypervised, if it's hyper-threaded, and how many core it have. If you have here, if you are here less than strictly inferior, sorry, of the number of CPU that Windows see, you are hypervised. For example, if you configure your Windows, okay, you tell that you have two CPU, okay, so Sandbox should be okay. But after that, if you take a look at the CPU ID, it may give you 1 core per CPU. So you are tricked. So CPU ID is a good instruction. You have a lot of things in that. It should be disabled, I think so, but it's not possible. And with this instruction, you are able to see a lot of things. For example, other example, since Pentium 4, if you take a look at the leaf 8 million, it gives you the last support leaf. It says to you how many options are available. If you use that on Anubis Sandbox, for example, you are able to tell that you are using a CPU which is older than a Pentium 4, which is not possible normally. So again, CPU ID, a little mistake, you are able to see if you are in Sandbox or in the real world. Virtualization, little things also. So if I use CPU ID, I put 8 million in my EAX, I call CPU ID, and I have the last leaf supported. So if I'm in an Intel CPUs, if I have something more than 8 million 8, I have garbage. Depending on the CPU, garbage change, but I always have garbage. And on some VirtualBox, it's clean. It's a good development, but it's not the real life. So CPU ID is really useful to detect if it's virtualized or not. It's easy to implement, and it works. So, another things. So we will leave CPU ID for a moment. How to detect sandboxes without using APIs. Alors, we have to take a look at the PIB. The PIB gives you 3 chain lists, which are called the loader. You have the inloaded on model list, which are the DLL loaded at the start of the executable. You have in-memory order model list, which are the DLL running currently. And this one is really interesting, the second one. It gives you the name of the executable and the name of the loaded DLL at the moment. So with that, first, you can validate that the executable has not changed its name. I usually have some droppers that send me invoice.pdf space.exe, and I change the name to invoice.exe and something. With that, you are able to detect the name of the executable without calling any API. It works. You may list some DLLs, these 2 ones, for example. the Windows debugger. And the second one is a part of Sandboxes. Sandboxes is a host-based sandbox. So it's true, if you use Sandboxes, you avoid malware, because once malware detects the SBI DLL.dll, they stop. They are stopping. It works. You may also leak DLL installed by the sandbox. Little example. So I have my process memory. I have a sandbox, and the sandbox will want to log any network calls. So to hook the DLL function, it will load the DLL and hook the functions. So if I have a little program, this program need only kernel 32, MSV30, I will of course have NTDLL loaded. If I take a look at the in-memory order model list, when it's run, I have 3 DLL on my executable. If I run in a sandbox, for example Cuckoo, I have all the DLL loaded, because if it's hooked, it needs to be loaded. So some sandboxes are hooking all the DLL before the run. And in this case, you just have to detect if you have the network one, and you are able to tell that you are in a sandbox or not. So in a Packer, it's easy to do. And just have to stop, there is nothing in the log. You could also take a look. That is used. This one is used really. You just have to detect where it starts a function. And if you take a look at that, you have a lot of way to hook the function. Just have to take a look at the start of the function. You have the function prologue, which is quietly always the same. Sometimes you don't have it, but a lot of functions have this kind of prologue. And when it's hooked, the sandbox change with a jump or call or something else to jump to the function to log it. And you just have to detect that. If it's changed from that to that, you are able to tell that it's not normal. It's easy to do in assembly also. You have 2 functions which parse the PDB to find the DLL location, and you have a second function which parse the DLL to find the process, the API call. And just have to check the prologue. You are able to say if it's hooked or not. Other solutions? Jump. So little example. You have a program, okay? You just have to call a sleep, okay? So you jump in the IAT jump to the sleep, it chooses sleep exec, it jump the NTDLL execution, and do a center to go to the kernel. Why not directly going to the kernel? It's possible. It's hard to do because every version of Windows have some center, different center, but some strange guys do list of that. And it works. It's hard to maintain, but it also works, and the sandbox see nothing. The problem is when you have a sandbox that hooks kernel side. If it's kernel side, too late. You can detect the sandbox. So it's easier to detect the sandbox and stop than to try to fool it, because if you fool it, it's more hard and hard, and if it's kernel side hooked, you can do nothing. So it's easy to detect the sandbox and the stop. It works. Other things, you could reload the library. There is a POC available on GitHub, not mine, and it works really. You just have to reload the DLL, so from disk or from your memory of the executable. And once you have reloaded the DLL, the hooks are not there anymore. And again, the problem is when you use that, you are not detected, except when you are a kernel side hooking. So, how to escape of the sandbox? Another things. I know it's a very nice rabbit. So every sandbox has a time limit. If you run malware on that, it will run for a couple of minutes and stop, because there are a lot of samples to test. So you may issue just a sleep 5 minutes and start reading your payload. But it's not possible on some sandbox because they hook the time function. But that's used, really. So there's a lot of way to wait 5 minutes. You could take a look at the internet, take the time, load the pages, and take a look at that. You could use some function we are not hooked, get tick count, currently is using. Or you could process something. For example, I have done a RTDS loop. So RTDS loop, it's an instruction which gives you the count of the instructions that were processed by the CPU. So you are able to make a big loop. And this big loop, of course, you have the CPU which is burning for 5 minutes, but if you have a lot of CPU, it's not a problem. For workstation, normal workstation, you see nothing. And it may be possible to sleep a lot of time. And you escape the sandbox. In the sandbox, what did you see? Nothing, because it's only instruction. No API call, nothing. Playing for time. Alors, that's really funny. Some sandboxes remove the sleep. It's hook the function, and if you call a sleep, for example, at the beginning of the executable, the sleep is removed. So you could play with that. If you start 2 threads, the first one is a normal sleep, big one, and the second one just try to resolve something that is broken. In a normal computer, the second thread is ready a lot of time before the first one. If it's hooked, you have this case. So the big sleep is quitting before the result. So it's not possible. So what did you see in the logs? You see some sleeps and result host to update.mysite.com. So it's easy to fool the security guy. Other perks, it works for a lot of vendors. By default, sandbox are not able to talk to internet. Some could not at all talk to internet, and some could. You have to set up it, and by default, it's cut. So, if you make a simple POC, you download a file with inside something that is hashed by your request, for example, the host name of the workstation. And if you are successful in the decipher of the result, you could do your bad things. Since a lot of vendors don't allow internet access, what is using is sometimes they are feeding with fake files, and sometimes you don't are able to download files. So again, in log, you have just an URL download, and that's all, finished. So it's not enough to trigger the triggers the way that the triggers that it's malware or not. Virtualization. So, well, every virtualization is possible to be bypassed. It's not easy. There's a lot of work of that, but with all what you saying before, I was able to trick some sandboxes. And on the detection, again, it's possible. So for Sandbox, I didn't succeed. Because the Sandbox has a good thing that a sandbox run your malwares, but it's run only part of the malwares, the part that it's running. Sandbox do a static analysis and try to go where it's not allowed to, where it's not supposed to do. If you have part of code that is not normally run, it go on that. And if you only run in the sandbox, you only have a part of the malware which is run. That's a big difference, and that's why it wins. So to mitigate, to configure yourself your sandboxes to have less problem in detection, so use many CPUs. And if you have the choice, for example, for VMware, use many cores, not only many CPUs, but many cores per CPUs. And you have to tune your CPU ID, just to tell him that's not telling that it's a virtualization. So no virtualization tools, never install your virtualization tools. You will not modify the history, for example, of internet browser, and it could be detected. That's a problem. Use virtualization everywhere. It's a solution for protecting your workstation. Use VDI, for example, and use multiple sandboxes, because sometimes it works on a sandbox and not on another. Good links, very good links. The first one, it's a hardening guide for VirtualBox. It's the most complete that I never see, and really a good thing. The second link, it's automatic tools for Cuckoo. So it's automatically try to cloak your VM. It's not perfect, it's still young, but it works. My test suite, so most of the tests that I've done here are available. You could test on your sandbox if it's detected or not. And the next one is coming soon, a paper of some two guys, and they have completely passed all the well-known sandboxes. So I'm really impressed to see that. So sandboxes are not magic. It's definitely a good thing because it helps a lot, but it's not magic. You have maybe have a problem with that, so don't rely always on sandboxes, but you keep a lot of time with that. It's really easy to detect the sandbox that bypassing a sandbox. It's easy to detect it, and you just have to stop your process in your malware. It's easy. The sandbox is not detecting the sample, but trying to do something with the sandbox, that's another story. So, and malware are using detection. That's clear on droppers, and you have a lot of simple things, but things that works, serial numbers validation, driver validation, and so on. Thank you.
Okay, we have time for one quick question. Who's volunteering to do a quick question?
Hi, thank you first for your talk. The question I have is about FireEye. The system is homemade, so how did you manage to bypass the system?
Quite funny. So I've wrote a little packer. Okay. I take a sample which is flagged red because it's a real red one. And for each test I have put the test in the front of the packer, which, if it's detected, stops the process. So it's not unpacked, and it's the malware not launched. And I have written what is working, which is red, what is not working, which means nothing. Okay.
Okay, 30-minute break.